Welcome back to S2. Today we're looking at Unit 3.4, choosing the appropriate approximation. Now this is probably one of the hardest things that most students like yourselves face. Choosing when to use, a normal approximation, when you might use a Poisson approximation if you started with binomial. Luckily for S2, if you've started with Poisson, and it does ask you for an approximation, your only option is normal. So, in that case, it's not so bad. Binomial is obviously the one that will catch most people out, or the most likely to catch people out. So let's have a little look at what we've got. Now, if we start with binomial, and we think of what we were doing, binomial will, or can be approximated with Poisson, provided that n is large and p is small. So as long as n is large and p is small, we can approximate binomial with Poisson. And remember that Poisson is lambda, and lambda is simply np. Now, binomial can also be approximated with the normal. So I'll pop the normal over here. I quite like the way it's done in a few of the textbooks. So I'm going to keep a similar method. So here now, if n is again large, so we can go this way, n is large, this time p has to be close to a half. So here you can see really the difference between the two. When you look at an approximation, it's whether p is small or p is close to 1/2. Now again, that's not always helpful. So what I would say is when you're doing this kind of approximation, work out np, which is your mean for both. And if this is less than or equal to 10, then you should be able to use Poisson. And if it's greater than 10, then you would use the normal. And that's a good way of checking it out. So that's the binomial done with. So starting with binomial, we can go to Poisson, as we said, or normal. So remember, the only difference is p, but that can also be a little bit confusing sometimes. So as I said, multiply them together for np. Less than or equal to 10 should be Poisson. Greater than 10 should be binomial. Now, for Poisson, our only option is a normal approximation. And the only requirement here is that our lambda is large. You'll notice in the tables, lambda only goes up to 10. And all questions you should be able to do with the tables, not just with your calculator. So, if you get a value of lambda that is greater than 10 within the question, then it is implying that you're doing a normal approximation there. So that's, that one's quite straightforward. If you've got a Poisson question and it asks you to use an appropriate approximation, well, your only option is normal. Now, there's a little bit more than just that. So, as we talked about before, binomial and Poisson is discrete data. So, if I'm changing between binomial and Poisson, following this line, then I don't need to worry about anything. But if I'm approximating either binomial or Poisson with the normal distribution, then the normal distribution is continuous data, isn't it? Which means that we need to use continuity correction. So when you go from either of these two to the normal, we need to use continuity correction. And a nice way they show that in a lot of the textbooks and online is just with a simple line, which I'll pop in now. And there we have it. Cross the line, and you need to then use continuity correction. Okay, remember when you are doing that, just same as like I always say, to avoid making mistakes, change everything to a less than or equal to or greater than or equal to first, and then do your adjustment. That way, that consistency of doing it that way in every question will mean that you'll start doing it almost without thinking, and you're less likely to make those mistakes than if you try changing from a greater than or a less than mixed in with less than equal to and greater than or equal to. So I think the best thing to do here is to look at some exam questions. What I'm going to do is I'm not going to do any examples on this video. What I'm actually going to do is I'm going to do a question and then the answer, the work through. Question, work through, question, work through. That way then you can pause the video, have a go at the question, mark it before moving on to the next question. So here we can see a cafe serves breakfast every morning. Customers arrive for breakfast at random at a rate. So there we have that word rate. Seeing that, we pretty much confirm that this is Poisson. And we can see the rate is 1 every 6 minutes. Now for A, we've got between 10 and 11 a.m. So that's 1 hour, isn't it? 60 minutes. So we think 1 every 6 minutes. So in 60 minutes, there will be 10. So my lambda is 10. So we're looking at our distribution as follows. X is distributed using Poisson, where our parameter is 10. So we want to find fewer than 9. So we're looking at the probability that X is less than 9. And that's the probability that X is less than or equal to 8. So this should be nice and easy, very straightforward one. Less than or equal to 8, value of lambda is 10. We can look this straight up in our tables. And here we can see it is 0.3328. Now moving on to the second part, we can see the cafe serves breakfast between 8 a.m. and 12 noon. So that's going to be 4 hours, isn't it? Okay, so value of lambda for 1 hour was 10. So for 4 hours, it's going to be 40, isn't it? So we've increased that value of lambda. Lambda is now large, so it should be an approximation. And as you can see here, using a suitable approximation, estimate the probability that more than 50 customers arrive for breakfast next Tuesday. Now, luckily for S2, we only have to think, well, we got Poisson, has to be approximated with normal. Okay, and we do know that because lambda is large. So this is going to give me that Y for normal is going to be 40 and 40. As if you remember, our mean and our variance are the same. And what we're trying to find is when Y is greater than 50. Well, I suppose technically it might be X is greater than 50 initially. Let's write it that way around because I think that's a little bit better. There we are. So what that would mean in terms of our Y, well, before I get to our Y, I'd always want to make it a greater than or equal to. So if it's greater than 50, it has to be 51 and above. And that means then in terms of my approximation for Y, this is going to be greater than 50.5, isn't it? So I've got that all set up. Let's just make a little bit more room. Now that we know what we're doing, I also usually like to do a sketch, especially if I'm in an exam, it just helps me think the question through clearly. So we know mean is 40, we've got 50.5, and we're looking at greater than. So now we can see that it's actually a 1 minus, isn't it? So this is going to be then, if I carry this on down here, this is going to be equal to 1 minus y being less than 50.5. Remember, with normal, it doesn't matter if I have an equals or not an equals with my inequality, because it's continuous data. So now I've got that, I need to turn it in terms of z. So I can do that within the question, or I can do it separately. I do often like to do this separately. I just find it a little bit easier that way. So let's just pop this up ready. So over here we've got our 50.5 minus 40 over the square root of 40. Obviously, if you were going to put it in the question, just put that straight in here. Or like I'm going to do is I just put that value in. And this value is going to be 1.66, which I will pop there. Okay, now if you're using your calculator, you can use your calculator to do the normal. And if you did, what I would say is use that full value of z. If you're going to use your calculator, if you're going to use the tables, obviously use the rounded value, and you will be slightly off potentially, but it shouldn't be anything to worry about. And you'll notice in a lot of the mark schemes, they'll give you like an answer from the tables, an answer from the calculator. Here you can see my 1.66 gives me 0.9515, and 1 minus that is 0.485. Oh, sorry, I missed out a 0 there. You get rid of this. 0.485. There we are. And that is a good enough answer there. That's from the tables. If in this case you used your calculator, you would have got 0.0484 and a few others. So that's from the calculator. So if you do use that full value, you can see you will just get a slight difference there. Okay, it's 0.484, and the next number is actually 4 as well. And that is this question done. Quite an easy question, this one. So if we look at it in the beginning, each cell contains 11,000 genes, and the probability is 0.0005 being damaged. So we've got N and P, haven't we? So you can see that this is clearly going to be a binomial. Suggest a suitable model for the distribution. So there we have it. Binomial, N is 11,000 and P is 0.0005, and job done there. Part B then is find the mean and variance. So our mean, or E of X, however you want to, whichever kind of symbols you want to use here. This is going to be 11,000 times 0.0005. So, and that is 5.5. And then we want our variance, don't we? So again, it doesn't matter whether you use a symbol or VARX, totally up to you. So this is going to be N times P times that 1 minus P, isn't it? And that will give me 5.4975 725. And I definitely would write this one out in full before kind of thinking about maybe rounding it off. If I did round it off to 3 significant figures afterwards, so 5.50, I could, but I do need to make sure I have that one in full first, because, you know, if I just wrote 5.5, you know, it is almost 5.5. We do need to really show that it is just slightly off, but it is pretty much 5.5. So part C is about a suitable approximation. Now this is obviously binomial, as we said, which means binomial can go to Poisson or it can go to the normal approximation, can't it? In this case, I don't necessarily think about looking at whether, you know, it is obvious, you know, we've got n is very large, p is very small, isn't it? Okay, which will imply a Poisson anyway. But from part B, it's really obvious, isn't it? Part B, our mean and our variance are pretty much identical. And if your mean and variance are the same, that is one of the definitions for a Poisson distribution, isn't it? So, you know, there's 2 different ways there that you could get to Poisson. But it should be quite obvious for you. So y Poisson, and this would be 5.5. That is what they both round off to, but it's also NP, which is what lambda is. Now we're trying to find the probability that there are at most 2 damaged genes in that cell. So at most 2 damaged genes. So we're looking at y is less than or equal to 2. And 5.5 is a value that is in our tables, so let's bring those up. And here you can see it, so it's 0.0884. Nice straightforward question again. Okay, the difficulty really comes in that beginning, making sure you're comfortable with knowing whether a question is binomial or Poisson. That is the key thing. Once you've got that down, then it starts to get much easier. So looking at this question, we can see that in a large college, 58% of students are female, 42% are male. Random sample of 100 students is chosen. So we've got a fixed probability, we've got a fixed number of trials. Using a suitable approximation, find the probability that more than half the sample are female. So I think it should be quite obvious that this is initially a binomial. So we're looking initially like this, 100, and we're dealing with female, so our percentage is going to be 0.58. So that's where I'm starting. Obviously now we need to kind of look at an approximation. So approximating this now, if you remember, it's going to be NP. So approximate the normal. Mean is NP, 100 times 0.58 is going to be 58. And then our variance is NP multiplied by 1 minus P. So that would be 58 times 0.42, which gives me 24.36 exactly. Now we want more than half, don't we? So we're looking at, let's make a little bit more room up here, probability when y is greater than 50, which is obviously y being greater than or equal to 51. I suppose really I should be saying this as x, shouldn't I? Let's do that as a change, because that's what we're talking about. When I estimate this, that's when it's going to be turning into my y, and that's going to be greater than 50.5. Okay, so don't forget that continuity correction. As usual, just going to do a very quick sketch. So if I think about it, the mean is 58, isn't it? And we are looking at greater than 50.5. So that is what we're trying to find here. So first find my value of z. So 50.5 minus 58 over the square root of 24.36. And that gives me minus 1.52 to 3 significant figures. And as you know, flipping this around will give me this diagram with a positive 1.52 there. So that's what we are basically looking at, aren't we? So this is the same as z being greater than minus 1.52, which is the same as z being less than 1.52, but the positive one. And this then I can write up, or look up I should say, in my tables. That gives me 0.9357. And if you use the calculator, you would have got 0.9357 as well, 69 it was. So in the calculator, same answer to 4 decimal places there. Okay. Hopefully you found this video useful. I know I've only done 3 questions. What I would suggest is try as many of these questions as you can. And if you do find a past paper question that is particularly challenging, even if you manage to solve it, think this is particularly challenging, and you think it's worth me making a little video on or a few questions, then please send them through to me.